Okay, hello everyone. Welcome to my book. Thank you for visit. My name is Firna. Now I'm working as officer under exploration and GSR department at the Kutai Energi. Today is a good day, and I'd like to present our project with title Paleoenvironment of Steenkool Formation Coal. That's on Facies Association at Teluk Regency, West Papua province. There are three authors in this research. I'm as the first author, Naurah, and Professor Ahmad Helman Hamdan as co-author, and Mr. Febriwan Mohammad from the Faculty of Geology, University of Pajajaran as co-author. All right, this project worked parallel with preliminary study of coal resources in Teluk Bintuni Regency. So in this poster, we would like to underline the model of paleoenvironment of coal deposit that occur in Birds Head, Papua. As we know, Birds Head, Papua and its surrounding area has got a lot of natural resources. One of these resources is coal. Maybe you ever heard about metals, oil and gas, and many more. But one of these natural resources is coal. But it's found rarely to research about coal in Birds Head, Papua. We assumed because the situation is quite difficult and dangerous from infrastructure or social economic aspect. And also the geological condition of Birds Head, Papua is quite complex. But we are trying to describe a model about coal paleoenvironments in those situations. Why did we find this research? I will try to explain through this poster. So there are 4 types of methods that we use in this project. First, we compile data from surface and subsurface. We compile surface geological data. Here we use outcrop sample from subsurface geological data from core and well logging data. And as additional but important, we use coal quality data from laboratory analysis. And second, we group in similar lithology. We group similar lithology and we group a Facies from lithology that those have similar characteristics. And the third, we made a correlation. We made a correlation regarding the Facies association for each report that has similar data. Take a look at this report correlation. And last, we made a paleoenvironment model. From 1978 to describe a paleoenvironment model about this research area. Okay, now I will tell you about what did we find in this project. From lithology, we used a representative borehole from one line from west to the east. After we group a similar lithology, we have the 5 facies here, namely first, coal facies. Coal facies is the key facies. This is our research object. The coal facies has approximately thickness between 0.2 to 1.2 meters and generally 0 to 70 meters below the surface. They have got dark brown streak, brittle, hard, and contains a lot of joint and has a sulfur content more than 1% ADP. And we got total sulfur content from laboratory analysis that I've told you before. And the second facies is sandstone facies. We divided sandstone facies into 2. There are sandstone facies 1 and sandstone facies 2. But they have a different homogeneity of grain size. Sandstone facies 1, take a look at the letter here in the yellow ones in yellow. And sandstone facies 2 tend to be constant, homogeneous. Now I'll tell you about the physical characteristic of the sandstone facies 1. They have got 2 until 50 meters of thickness, brown colored, medium, coarse grain size, subangular and subrounded form. The hardness is quite hard, and also we found a sedimentary structure like parallel-elimination and cross-elimination from outcrop data in Sentinel species 1. And the second is Sentinel species 2. It also has the same characteristic with Sentinel species 1. They've got a brown color curls, coarse, and coarse to medium-sized grain with subangular to separated fur, and the hardness of is hard and non-carbon. But in Sentinel species 2, they tend to be heterogeneous and show shifting gradation in grain size from either fining or crossing upward. So that's why we divided the Sentinel species into two. Sentinel species 1 is more homogeneous and Sentinel species 2 is more heterogeneous. You can take a look from this correlation. Sentinel species 1 is A letters in below, and Sentinel species 2 is D in upper. They have the differences between heterogeneity from their addresses. And the third is we have the substance patches. It has two also found nation and predominant east than the west. Take a look again to this correlation in orange color in B letter. It is system Facies, and the last passage is mudstone patches. Mudstone patches has a characteristic of grain colored, soft to medium soft, carbonaceous, and often consists of fragment and phosphate. And mudstone patches is most outstanding patches we've ever seen in this project, because these patches can find an every borehole from west to the east. You can see the green ones in C letter here. This is mudstone patches. Okay, now let's move to the electropatches. From electropatches aspect, we found 4 types of gamma curve. Maybe as a wildlife geologist or exploration geologist, you've ever seen this curve or you're familiar with this curve. They are bulky shape. It is a long white curve, and it means the longitudinal recorded coordinate. So this is the key curve of our core characteristic. You will find a bulky shape in core lithology because it's record core lithology. And second is funnel shape. Funnel shape reflects feature coordination deposition and coarsening output. And the third is bell shape. It's recorded and finding output. And the last is serrated shape or tube shape. It usually reflects radiation and intercalation between fine grain and coarse grain. So the funnel shape and bell shape is opposite, where the funnel shapes record about the coarsening of it, the bell shape record about finding of it. And okay, now let's move on to the coarsening of the pattern. As a result in discussion here, let me show you this correlation picture again. Okay. From this correlation picture, we can see the siltstone patches and mudstone patches is predominate to the east. Okay, while sandstone patches tend to be thinner to the east and thicker to the west. So we can determine here west area is probably also free field, and east area is a transitional or mirror area because it's domination of lithology. So now we will bring you in the aim of this research about Paleoenvironment. Okay, from explanation before, we have a few data to determine the Paleoenvironment from the Facies situation. From all of the evidence, we determine that Paleoenvironment of coal it is in transition area. Why? Because we found the coal as patches associated with sandstone patches, mudstone patches, and siltstone patches as well. Like you can see it's the texture. Then we made a model that reflected from 1978 and we found that our search location is lower than Papua. We also make a comparison between our research area from digital education model. Pay attention in the red circle here. The location is our location is between fluvial and marine environments. Only divided into three area of the delta from colonization. There are upper delta plain, transitional lower delta plain, and lower delta plain. But in this instance, we would like to tell this specifically. Okay, and as additional, we also make notes about the impact of Paleoenvironment with seam and splitting. If Sunday government want to develop this area into mining activity as well, okay, we would like to tell you about this. The core geometry is not a chip, and it has 1% more than 1% sulfur content. It means the marine environment has given an impact to core quality. But in the other hand, a core calorific value is quite high. It's around 7,189 to 7,823 kilocalories. It's quite high. It's an evidence from the thickness of molten sediment can improve the core range by increasing subsurface heat. Even though the age of Steenkool formation is Pleistocene, but undeniable tectonic and sedimentation of birds' heads in Pleistocene has an impact to core cement splitting, because we know that molten sediment is kind of sediment, thick sediment from organic activity, and it's usually thick, but unconsolidated. Okay, now so from all of the compilation, we found Paleoenvironment of Steenkool formation codes in more delta plane. Okay, and we use a few references here from Smalinata, from Geology, geological maps, forensic sheet Miran Irian Jaya from Pusat Penelitian dan Pengembangan Geology, and from Casagrande, Sulfur and Steenkool. And the last is from GC Form 1978. The positional model in coal exploration and mine finding evaluation. We would like to say thank you to everyone that support this project, especially from me to my co-author, Professor Ahmad, Hamdan, and Professor and Mr. Febriwan Mohammad. Thank you. Okay, this is the end of my presentation. If you have a question, you can write through the chat box. Thank you so much for your time and have a good day.